All right, so today we are going to talk about how to run a program that was written offline. So step number one is you don't run a program that was written offline until you've approved it with the instructor directly. And while I may go through and grade your work ahead of time, that still doesn't mean that I've gone over it with the same fine-tooth comb that's required when you run it on the actual machine. So if you don't know where your file is, you can always go download it on Blackboard. In this case, I have already downloaded my file from Blackboard, and that comes down as a zip file. So I will right-click on it and say Extract All. And there's my file right there. Now, one thing to keep in mind is when you're browsing through your File Explorer, you notice that in my Downloads folder here, I have this PC, Downloads, I have the folder name, and then a zipped version of the same folder. You do have to go through the unzipped version of the folder. So one thing I'm going to do, I'm just going to delete that zipped folder so that way I don't accidentally go in there. Right? And now there's only one option. Now notice that this comes along with a whole bunch of files. Now in the first couple of weeks here, I told you to only give me the inspection file. I thought I mentioned it in this video, but maybe I didn't. I do actually want the entire working folder with the CAD model and everything. So some of you just saw why. You went to open up your files and you had only submitted the inspection file. It opens up a couple of surfaces and nothing else, right? So then you can't see what's going on in the simulation. That doesn't gain us anything. All right, so we want this entire folder structure as is. So now I'll just say Open Measurement Plan now that that's extracted, and I'll come up to my Downloads folder, and there's our only option. We'll open up the inspection folder and say Open, and we should find, hey, all right, so that opens up with our entire CAD model there, with our gnomon in the correct position and all that jazz. So right now if I look over on my CMM tab, I have not even put a probe in the machine yet. In fact, looking at the machine, there's no probe there, so that makes perfect sense. I'm going to go into simulation first, so I'll turn this speed dial all the way down, so that way I don't accidentally get myself in trouble. So as far as I know, these computers are currently working how they should have been working the whole time. Hopefully third time's the charm on this reformat. I did reformat them again very recently, so bear with me here on the off chance I didn't get it quite right. So we'll come into CMM settings from the CMM tab, and we'll click on Simulation Only and click Connect. And this is actually unmounting the CMM, or I should say it's unmounting the computer from the CMM. So you may notice that your probe goes from defined to not defined. You may notice it goes from green to red during that process. That's normal. So this is actually one of the most dangerous things about simulation, by the way. You can get a mismatch between the probe that you're using in simulation versus the probe you're using on the real machine. This is like the #1 way to crash this machine is by having the wrong stylus on there and then going to put that stylus away when there's already a stylus over there. So that's really our main concern here. And I'll show you all the proper ways to make sure that that's not happening. And that, by the way, is why I'm so big on this speed dial, and I mention it every time, is to make sure that that doesn't happen. All right, so I like to reconfigure my window a little bit. Let's close down some of these windows. The Calypso monitors in the background, I say do not record, and I close down. Our status window, it's going to keep popping up no matter what you do, so you might as well close that one down. And I don't need this extra File Explorer window. The next thing I'll do is grab my stoplight window and dock it in the upper right. And I've found that this is a great way of doing it. You just dock that in the upper right, you dock Calypso on the left, and now your screen is auto-sized. So do whatever you want. That's what I found works the best through trying it in many different ways. All right, now the next thing is let's go into Planner and Measurement Plan Simulation, and let's drag this window, and on this size monitor, it fits oh so perfectly right there. You may find this helpful with your laptop at home. If your screens are not as tall, you may find that you want to resize this window or perhaps pull it up so that it's just below the XYZ readout. That can be helpful as well. Another thing I like to do with this stoplight window, this resets itself every time you turn our computer on, so you'll have to do this every time. Just switch that to base alignment. So that way when you read out where your probe is, those XYZ numbers make sense. Otherwise they're coming from machine position, and machine position is way back here somewhere. It doesn't mean anything to anyone. Right? So also in our simulation window, I think I may have said something slightly different than this in one of the videos, so for that I apologize. I would put this in your notes with a giant star next to it. Do not hit the pause button in simulation. If you do, yes, it works, but at some point you're going to try to take a probing hit on something and it will freeze the computer. So if at all possible, I try to stay away from pause mode. If I do put pause mode on, I pause it to see whatever I need to see, and then I immediately hit play afterwards as soon as I can. Right, so watch out for this pause button. I'm sure you'll all do it to yourself at some point. You'll say, let's see what Tom's talking about with this pause button. Is it really that big of a deal? You'll pause it. You'll completely lock up your system. I hear somebody laughing back there. That's obviously already happened to you. And if and when, if and when you do freeze your system, you can do a Control-Alt-Delete. Go to Task Manager, and the name of Calypso is vwnt.exe. Right, so just go in there and force close it. I've done it to myself upwards of 10 times already. And I already know that, and I keep doing it anyway, right? So fair warning on that. So try not to use the pause button. Now the next thing is grab your speed slider, speed that all the way up, and then use the mouse button, or I'm sorry, the arrow keys on the keyboard to go just one to the left. So that way it's going to give you the fastest simulation. Here's a hokey thing about simulation. It does not do collision detection if you're at full speed. If you are even one click away from full speed, it'll do collision detection. Why? I don't know. Call Zeiss, ask him. As far as I know, it's just a bug in the software. Right? So the next thing is my default settings. I show the stylus system. I like to show the base plate as well. So what is the base plate? Well, let's come down here and let's go to fit. So when we fit this to the screen, we see the base plate down here. We see our part up there. So Calypso thinks that our part is in space right now. Why? Because this part was programmed in space. In the video, I even told you, you can move these parts. We're not worried about it yet. Let's take a look at our whole CMM. So this is show base plate. Let's show the entire CMM. So it thinks our part is way up there at machine home position. Clearly, it's not. So because this has not been placed in there correctly, checking measurement range isn't going to mean anything for us, right? Checking measurement range can be very helpful if you have large parts or indexing heads. You want to make sure that your part fits inside the machine. All right, so a lot of times I use this show CMM dialog to just place my part on the machine to begin with, and I try to place it on the machine somewhat central. The software has a great little checkbox for that. So that way you have the best chance of being able to fit big parts in the machine. Once you place the part, to be honest with you, I don't use the show machine at all. If you want to know where your part is relative to the travel of the machine, you're welcome to use show base plate. The one to the left of that, which is called show probe, that one is pretty much never helpful. That just shows this portion of the probe right here. It basically shows the z-axis of the machine. All right, so a lot of times if you're using show base plate like this, when you go to rotate the model around, it seems like it rotates from really far away, if you will. You see how it's kind of rotating off the screen? Okay, well let's turn show base plate off, and then we'll do a fit, and you see how it now fits to only the CAD entities that are on the screen. Sometimes I show the base plate. A lot of the time I end up doing this, so that way when I rotate the model, it rotates how I think it should. Now let's do a quick rotate here and see if it looks, oh yeah, that feels about right. If it feels wrong to you, you can right click and say define rotation point and click anywhere on the model, and that will change how it rotates. That's an extremely helpful trick for programming in this software. And also, somebody's gonna laugh at this. If you don't have a mouse, get a mouse. Right? It's almost impossible to program in Calypso without a mouse. You need to have a mouse. So if you're on a laptop and you're trying to do it with just these keys, I recommend you invest in yourself. Invest in your future. I don't think a D-pad's really good enough either. So to each their own, but I wouldn't do that to myself. Yeah. All right, so let's do a fit quick, and then let's hit the pull down or pull up here and go to isometric. All right, so there we go. So let's come over to our characteristics tab. And in theory, all of your characteristics would be filled out. But I have seen it in the past where all the characteristics are not filled out. So then when you go to run the simulation, you run it, simulation says it's fine. Well, you weren't paying attention to the fact that you only measured like 3 features, and they were your alignment features. And then it turns out there are more features than that in your features window, and those features are the ones that crash. So does it make a difference whether you execute from characteristics list or features list? Not really. But the way that I want you to run it, features is what drives the machine. Characteristics drives your dimension report. I want you to click on the top item and then do a Control A on the keyboard. So hold Control on the keyboard and press A. I don't know if that's showing up in the video there, right? Control A on the keyboard, and that will grab everything from your features list. And this way, I'm 100% sure anything that's driving the machine is going to be executed when we do the simulation. Why? The whole point of the simulation is to make sure that you don't crash. So again, I'm going to come around with each one of you individually and review this anyway. But if you already know how to do this, it will be less for me to explain when I'm standing behind you. All right, so now we just hit run. And for our run window, we are going to say clear existing results, default PyWeb reporting. For our alignment, we can go with manual alignment. Instead of all characteristics, which works great if you have a characteristic for every feature, but I don't know that you have a characteristic for every feature, I want you to do current selection. What does current selection mean? Well, it means whatever is currently highlighted on the screen. We went to the features list and highlighted everything on purpose. All right, so we're going to run from feature list for order, clearance plane. In this case, I'm not going to bother doing step mode. I'm going to do slow through first feature. It's less clicking on the screen when you're in simulation. And then for speed, 40 millimeters a second is fine, and I will hit start. It says current stylus system not defined, run will be canceled. I say okay. I get a whole bunch of alarms popping up. It feels like you're doing something wrong. Nope, that's just Calypso for you. We can close out of your status window. We can turn off display at CNC end in the info on the run video and close that down. And then our stoplight turned to red here, so we'll turn that to green. And let's go see what we did wrong. Well, our simulation CMM thinks that we have no stylus. And yeah, in the real world we have no stylus, but in simulation you can put on whatever you want. So let's go take a look at what's being used in this program. So we'll come into the measurement tab, we'll come down to feature or measurement plan editor features, and then up here on the pull down window I'll go to stylus system and stylus system. And it looks to me like we have 2 blue stars and then it says 3 by 50 millimeter stylus. Okay, if you see anything in blue, that means that you've accepted the default. It means that Calypso took its best guess at what you want to use, and that's what it's using. The problem with that is, that means it pulled whatever probe you had in there whenever you started this file. We want to make sure we have all black text in all of these dialogues. Otherwise, it's Calypso taking its best guess, or what's even worse, it's pulling the system default off of your computer's configuration. And who knows what that is? I'm having all sorts of issues with the computer configuration, so I don't really trust that. So the big ones we have to look at. Well, let's take a look at our stylus system. We'll do a Control A to highlight everything in blue, and then we'll hit the pull down and we'll just say 3 millimeter or 3 by 50 millimeter. And I wasn't sure why it did this when I was new to the software. And that was just a couple weeks ago, right? It colors it blue if it accepted the defaults. It colors it black if it's locked in. So if you see black, that's good. That's why we were having all those issues in weeks 1 and 2 when we were trying to run this, and when we got that error message that popped up that our stylus system didn't match. Sometimes we'd say change them and it would change them, and other times we'd say don't change them and it wouldn't. You know, who knew what was happening? This is, you're 100% sure you have the correct stylus system. All right, now we can go check our stylus as well. It looks like it did select the proper stylus here. Some others that I like to check. We'll hit the pull down and we'll go to travel and clearance group. Notice that we have CP plus Z, and then minus X here. We have one clearance plane that is not what we would expect it to be. Well, our probe only points straight down. This is the one we're going to be using. It's the 3 by 50 millimeter down probe in the real world. So all of those should be CP plus Z. So we'll do a Control A, we'll go CP plus Z for all of them. For our clearance distance, notice that that has been set to star 0.3937. Well, that's because in the default system of whoever wrote this program, that's their default. Well, in one of the manuals that I have that I got from training, it tells you the first thing you should do when you set up your Calypso is set that clearance distance to 0. I didn't relay the message to all of you. It's not really going to hurt anything, but it will cause some very weird movements. So I'm going to go through and set those clearance distances all to 0. I can also show you all how to set this in your configuration at a later date. Don't worry about it now. We can always override it here. Now our retract distance, that was 196 thousandths by default. I'm going to grab the alignment features. That's plane, 2D line, and point 1. I'm going to set them to 0.25. Why am I setting those to such a big value? Well, 0.25 is 1/4 of an inch. When we're finding the part, we might be in a slightly incorrect spot. That gives us a little bit of wiggle room to find where the part actually is. For the rest of the features, I just want to make sure that I fit inside of these holes. And yeah, they're not super small holes, but imagine if those were the holes we're measuring. Those are quite small. Let's give ourselves the best chance of fitting in. By the time we execute any features after the alignment, we pretty well know where the part is. So let's set our retract distance to 50 thousandths. So I highlighted the rest of the features. They're highlighted in blue now. I type in 50 thousandths, and now they turn into black text, which is a good thing. One other thing we may want to do is arc motion mode. That's set to on for all of these. That's just painful in the simulation because you have to watch it do like a really slow circle. When it's touching here, it goes touch, slow, 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 touch, slow, 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 slow. So if that annoys you, and it should, because it annoys me, all you have to do is come in here to arc motion mode and set that to off. All right, that'll make it travel in a straight line from one to the other. All right, so there are some others that we could play around with. Those are really the big ones that I do all the time. I'm going to write this in a standard operating procedure and just throw it up on Blackboard at some point. I have not done that yet. All right, so there we've set our defaults. And the last thing is, now we know which probe we're using. And Calypso currently thinks that we have no stylus in there, which is true, right? When we started up the machine, we didn't have a stylus. Then we went into simulation. We still haven't put a stylus in there. So let's go grab a stylus. Now, when we do this in simulation and we're fully offline and we're not connected to the machine, this probe changer rack will not be defined. You probably noticed that on your own system. Just out of force of habit, you click that little A and you go to change this and it says wrong changer position. Has anybody gotten that? Show of hands. Okay, it just means you haven't tried it yet. As soon as you try it, you'll see what I'm talking about. What we do instead when we're offline, and this is ironic, when we're offline, we do a manual stylus system change. When we're on the real machine, we do an automatic or CNC stylus system change. The real reason is I know where those are because I use the master probe to find them on the real machine. With your offline versions, there is no master probe that exists where you can drive it over and touch off to those racks to find them. Okay, that's the explanation. The bottom line is if you want to change probes in simulation, it's easy to yeah, you can do it a bunch of different ways. It's easiest for me to show you the one way that always works. And the one way that always works is called manual stylus system change. So click on that, click pick up system. It tells you to insert it. When it tells you to insert it or it tells you that a probe is about to drop, that dialog means nothing on our configuration of machine. There is no logic in here. If you have a VAST sensor, it's electromagnetically held on there. And if you press that and you release the stylus, it'll give you a little counting 1, 2, 3, 4, 5. If you're not there to catch it, it will drop the multi-$1,000 system onto the table of the machine. So that's why they have the warning. Okay, they just put it in Calypso. It is not specific to this machine. My point in telling you this, the manual stylus system change is extremely friendly on this machine. However, when you do a manual stylus system change on the real machine, you can end up with a misalignment where the machine thinks this is on there, but that is really on there. That's the thing that we have to watch out for. How do we watch out for that? Common sense and keep that speed slow. We'll run into this in a couple minutes. So don't say I didn't warn you. Also keep your hand on that speed dial. This is the most dangerous part in the semester is when I, push all of you out of the nest and we see if you can fly or if you're going to splat on the ground. Splatting on the ground is fine. I just don't want you to take the machine with you. You know what I mean? All right, so we're going to select 3 by 50 millimeter probe. We'll say OK, and then we'll say close. Hey, look at that. What do we have now? Well, we have the entire VAST sensor plus this probe here. Now, some of you probably realize that your probe in your simulation at home does not have this little blue knuckle here. You know what that's about? Turns out the documents I gave you for how to set up your system initially, which I got from Zeiss, tell you to put the wrong size probe in there. They tell you it's a 3 by 50 millimeter probe, and it is 3 by 50 from the very tip to the shoulder. However, our measuring length on this one is 41 millimeters. It shouldn't affect you for programming, but that's what was causing the simulation to go haywire. By the way, these ones are all the wrong length as well. So if you set yours up as the document said, which I'm sure you did, they're all the wrong length. Again, it's going to be fine for you for programming, but that's another reason why your simulation may tell you something's clear, it's not going to hit. On the real machine, I've updated this to match our real probes. So this one may tell you it hits, whereas your offline one doesn't, and they're off by like 6 millimeters. So anyway, we finally got to the bottom of what was causing it. So anyway, there is our probe. Now we can go through and go to our Features tab. So I said a whole bunch of words since we initially selected all of these features. It's very easy to forget. What do I need to do before I run this? Well, really, I cleaned up the file a bunch. And then I came in here to the Features tab, and I did a Control A to grab all the features, or if you want, you can do it, click on the top, hold Shift, click on the bottom, that works too. As this feature list gets longer, you'll probably start liking the Control A method a lot better. That's the one I use. And then we'll hit Run, and we'll see if any of this stuck. Let's see, clear existing results, PyWeb reporting, manual alignment, current selection, feature list, clearance plane, slow through first feature, and 40. All right, we'll hit Start. And what do we have? We have the manual alignment window here. All right, so we can do a manual alignment right in here in Calypso. Now here is where I froze my computer up multiple times. You would think I would learn? I don't learn, apparently. This is where if you have the pause button selected and you try to take this point, it will freeze Calypso. Why? Because simulation is overriding everything. Simulation, if you're in pause mode, the probe can't move. When you click on the graphics screen like this, it takes a point. You see how the probe's moving? If you've told it that the probe can't move by putting it in pause mode, and then you try to take points off the model, that locks up the computer. So again, don't say I didn't warn you. You will all probably do this to yourselves. Force close the VWNT if you do. All right, so it's just prompting me on the screen, and basically I'm clicking on the yellow arrows. So that's the same thing as a manual alignment in the real world. All right, so all that prep for that. So we have a good program. How do I know I have a good program? Well, this speed dial was not at full, and collision detection is open. I'm going to go change something that's going to cause this to crash. I'll come in here to Measurement Plan, Feature Editors. I'll come down to Travel and Clearance Group, and I'm going to change the clearance plane of everything to -X instead, and then we'll come right over to Features List again. We'll select everything, we'll hit Run. I didn't need to leave it on manual alignment that time, but I guess it's not the end of the world if I do it with that there. All right, so everything looks fine so far until we get there. Now, this computer doesn't have sound on it. On your own laptop, if you've used Collision Check yet, you probably heard it go, makes this cheesy noise in the background. Notice all these collisions that have been logged, and I can click on them, and it will show me where those happened. So that can be very helpful for troubleshooting. Now, I like to run at full speed initially, and if I don't see any crashes, at least I know it's not going to break anything, so I'll go ahead and run it on the machine. It's a lot easier to see what's happening on the machine than it is on the simulation. Okay, let's watch this as well. Let's right-click and delete our collision list. Let's max out our speed on our measurement plan simulation. Let's re-highlight all the features and hit run again and hit start. And notice that it's running through the entire program. And instead of logging all 4 or 5 collisions that it had before, this time it only logged 1 collision. Just proving the point that if you run simulation at full speed, it doesn't do a full collision detection.
Was that the first collision though?
Yep, well either way. So I'll run exactly the same thing. I've now done exactly the same thing as last time. I'll just slow that simulation down just 1 click here. I'll clear the list. I'll hit run. I'll do everything exactly the same. We'll still do the manual alignment. Alright, and it already logged 1 collision. There's the second collision. There's the third collision. There's the fourth and the fifth collision. So the rule of thumb is, in simulation, just leave your collision check on unless you're trying to do something that's causing collisions and you'll worry about it later. Leave collision check on. All you have to do to turn collision check on is click on that little icon right there. And leave your speed at full speed, -1 click. All right, now what caused that collision? Well, that was the clearance plane that I changed. I changed them all to -X. Let's go back and change them all to +Z. I'll run this one last time. This time I'm not going to do a manual alignment. This time I will just use the named alignment. That's going to pull the name of whatever your file is. This file is off 11100 blah blah blah, whatever it is. It's always going to be the third one down in the list. So pick the third one down in the list. We'll say start, and now we'll just slow the speed down a little bit. Now here's where I'll talk out of both sides of my mouth, and I will put pause on. Here's the caveat with that. I have pause on. Before I exit out of whatever I'm doing, I'm going to hit play again. Otherwise it'll freeze Calypso. So now that I have pause on and I'm slowed all the way down, I can do single block. I have a whole bunch of different things I can do here. It's interesting. I think I saw 4 points being measured there instead of 3. Or maybe, I think the video actually told you to measure 4 points. So the only reason I even mention it, you can see way more detail by doing single block than you can by hitting play. As soon as I'm done with that, switch it back into play mode. Otherwise, I'll freeze the system. All right, so did we pass? Yeah, everything looks good. So to get out of simulation, we will close out a measurement plan simulation. We see our probe go away. We'll come over here to CMM settings. We will uncheck simulation mode and hit connect. Now let's notice what our CMM tab looks like over here. CMM is green, stylus system is green, and it's set to 3x50. As soon as I hit connect, the system starts thinking. Keep your eyes over here on the CMM tab, and let's watch what happens to our stylus system. This will take, 30 seconds to a minute. It's got to recalculate where the machine is, find the probe that's on the machine, and all that stuff. All right, you notice that our stylus system went back to not defined. That's good. I have seen it where it will put the wrong probe in there. Right, like we didn't do any probe changes yet today on the real machine. We did do probe changes on simulation. All right, so that's good. I've seen it where I had the 1.5 by 31 millimeter probe on there. I went into simulation, I changed something to the 3x50, I came back out, and it put the 3x50 in the real machine. The problem was, I had the 1.5 by 31 in the real machine. So that opens you up to a potential collision. Alright, so let's go grab our probe now. Again, I'm making sure that my speed dial is all the way down on the controller. I am going to left click on 3 by 50 millimeter stylus and then right click and say load stylus. As soon as I see it starting to go grab the stylus, I can max out that speed, and it looks like we're good to go. Notice now that our CMM tab is completely green. We have the correct stylus there. So how do we run this? We'll do exactly the same thing that we did in simulation. Except now, when we move the machine, we'll move it using the joysticks. So I move over close to the part, I lower the speed all the way, and then I crack it open just a little bit. I'm aiming it right at the lowest part of the speed dial here, just so I see the machine start moving if it wants to move, so that way I know it's not frozen. We'll come over to the Features tab. We'll do another Control A, and we'll hit Run. And for our settings, we'll go Clear Existing Results, Default PyWeb Reporting. For our base alignment, do we want to use our named alignment? No. Do we know where this part is on this machine? No. Or maybe I'll ask the question a different way. What if I loosen up this part and move it over here? Would we have to do a manual alignment? Yeah, well, we've never actually found this part to begin with. We did our manual alignment, but we did it in simulation. Where was the part in the simulation? It was way up there. Right? In fact, if we look at our, let's close out of that for a second. If we look at our CMM system, our X position is 8 inch, 796, our Y is minus 12 inch whatever, our Z is minus 12 inch whatever. If we go to base alignment, our X is positive 8 inch, minus 12, minus 14. So that's where it's going to go to. It's going to try to go pretty close to our X0, Y0, Z0 if we just try to run the program right now. So we have to do a manual alignment so that our base alignment reads 0, 0, 0 when we're actually at 0, 0, 0. So that should say 0, 0, 0 right now. It says 7, minus 15, minus 14, right? That's definitely not right. That's one way to tell whether you need to do a manual alignment or not. All right, super helpful trick. All right, so I'm just repositioning myself. I'll hit Run, Clear Existing Results, Default PyWeb Reporting. We want manual alignment here. Current selection, Feature List, Clearance Plane, Slow Through First Feature. Let's switch that to Step Mode. This is the equivalent of doing a dry run, whereas the simulation that we just did was the equivalent of doing a graphic run. And then the speed is 40 millimeters a second. So now it prompts us to do our manual alignment. We'll do this with the actual joystick here. Try to touch the points on the model as close as you can to what it shows you on the graphics screen. Do they have to be perfect? No. But you certainly wouldn't want to touch 1, 2, 3 points for this top plane because you'll have a quote-unquote unstable calculation. If you take a bad hit like I just did, you can always come up here and just say delete probing point or change probing point. Right, so I'm following the graphics on the screen. This is showing you why you want to submit your zip files with your CAD models. This is really hard to see what you're supposed to do if you don't have the CAD model with you. The simulation that we just ran would be really hard to interpret if you didn't have the CAD model. All right, now it says caution, CMM being changed to CNC mode. Please move stylus system clear. Just move it out of the way, slow your speed down, and say OK. So now your step window will pop up. I'm going to slow the speed all the way down and hit continue, and then pull this navigation window out of the way. I'm just pulling it to the bottom right of the screen here. And then I'll speed up the controller. All right, so as soon as you see it start measuring the feature, you can speed the speed dial up as much as you want. When you see your step window come back up like this, slow your speed dial all the way down and hit continue. As soon as you see it moving again, you can speed that all the way back up. So we're running this under the suspicion that something might be wrong. Okay, so there's an instance where I would say that that's not good. You see how close that probe is to the top surface? I want to go figure out why that's happening. So what do? I'll come over here on our stoplight window and hit the red light and then the green light. And then I'm going to come over here into our measurement plan editor features, and let's take a look at our clearance group. This might even be a clearance plane issue. So I'll come up here to the measurement tab and click on clearance plane. Aha! And you see where it says clearance plane from CAD model? It looks like this clearance plane was set to 0 on the CAD model. This is something that simulation didn't pick up. So we'll hit clearance plane from CAD model, we'll accept the defaults, and you see how that clearance plane grew, got bigger than it was? My suspicion is the way that this happened is this edge distance was set to 0. You see how that collapsed it back to the size of the part? That's what the problem was. The default is 393 thousandths. That's an okay value. I like to go with something more like 100 thousandths, but if I'm being honest, sometimes I get lazy and just accept the defaults and everything runs just fine. It's arguably very, very slightly less efficient to do that. All right, so we fixed our clearance plane here. Do we want to update our clearance plane settings? You will always say no to this unless otherwise specified. We'll pull our probe off the part. Reposition ourselves to restart the program. Grab everything from our features list. We'll hit run. Everything is all still set here. We do not need to do a manual alignment anymore because I just did the manual alignment. Manual alignment is for setup and it only happens one time. If you remove the part and you don't have a fixture that locates you within plus or minus 20 thousandths or so, you need to redo a manual alignment. All right, so the only thing I'm changing here is I'm changing to the offline, or I'm sorry, the measured alignment. And this is going to go re-execute the same features that it just did. All right, see how that clearance plane looks much more reasonable? When it moved to the next point on the part, it lifted up significantly higher. And that looks much better as well. Now, some things that you may not see in simulation. Looking at the distance between the vast sensor here and the part, there's not a huge amount of room. So if you happen to select your point down here somewhere, yes, absolutely, the entire vast sensor could hit the part. You got to watch out for that. Yes, you watch it in the simulation. You also watch it in the real world as well, and I can't emphasize enough how important this speed dial is. And again, I'm not saying it every time, but every time I see that continue window, I am slowing that speed dial pretty much all the way down and opening it up just a trickle. All right, as soon as I see the machine move, then I can speed that dial up to whatever I want. Now, oftentimes you have to hit continue twice on that, whatever it's called, the single block dialog box there. That's because it has to move to its clearance plane first, or I'm sorry, its clearance distance first, and then its clearance plane. You don't need to know that level of detail. You just need to know you'll probably have to hit it twice, and that is normal. All right, so this appears to be running correctly. All right, and the one thing that I'll add to this program, now that we're going to be running production, quote unquote, with this program, I'll add a CNC end park position. So to do a CNC end park position, we'll drive over to a location where the operator would be able to remove the part. God bless you. We'll come in here to Plan, Navigation, and CNC end park position. We'll hit Create New. And then we'll come up here and click the button with the M and the K on it. It says position referring to master probe in MC system. And then say OK. And OK. Now you might be wondering, how come my dimension report doesn't have anything on it? Well, I ran from the features list, correct? Notice that my characteristics are all gray. That means they're defined. They know what they should be. However, I have not quote unquote run them yet. So I'll slow down the speed dial again. I'll come over to the characteristics tab. I'll click on run. I am not going to say clear existing results, because if I do, that destroys my point cloud that I just gathered by running my program. All right, this time I'm going to run all characteristics from current alignment. I'll go from feature list, clearance plane, step mode, let's just say slow through first feature instead, and hit start. And you notice it didn't even measure anything. That's what clear existing results does. Clear existing results is going to either destroy your point cloud or leave your point cloud intact. Now there are some instances when your point cloud does not have enough information to be able to output all these characteristics, and if that's the case, Calypso is smart enough to know, hey, I'm missing some information. I will go measure the features that are required to get that information. So it'll measure a partial list of features. So this will probably throw you for a loop as you do this yourself. Just know if you're not getting exactly the results you want here in your run menu, the biggest factor that will influence that is clear existing results. And to me, that button should say destroy point cloud or remove all your hard-earned points or whatever you want to call it. All right, so with that said, I'd like everybody to get to the point where their CAD model is on the screen like this. I will come by and run the simulation with you. If you want to try and run the simulation first, that's fine. Just make sure that your speed dial is completely 100% turned off, and make sure that you have set your CMM into simulation only mode so that way it won't move. You do need my explicit approval before you're allowed to run this on the real machine. I mean, you saw it. I have a decent amount of experience with this at this point, and I still ran a program where the clearance plane was literally dragging the probe on top of the part. And if we were doing that at a high speed, that would not be good. So you need my approval on the actual machine before you run it on the actual machine.
I have a question.
Give me just 1 second.